Hello YouTube, this is Mr. Bakari, and I wanted to make a quick video today about solving trig equations where we're going to factor out a common trig function, or a GCF. This is common practice in solving algebraic equations, and we can use this strategy with helping us solve trig equations as well. So let's look at an example. So in this first example, you can see that we've got sine and cosine within the same equation. So if we can move them to one side here, so what I'm going to do is I'm going to take cosine from the right and subtract it, move it over to the left. And now, as you can see, I've got two terms on the left side of my equation, and they both have a common factor, which is cosine x. So I'm going to factor out cosine x. Okay, so that should give me back cosine x times 2 sine x minus 1 equals 0. And you can distribute to double check that you did the math right there, and everything looks good. Okay, so now I'm going to take each of my factors and set it equal to 0. Okay, and over here I need to solve for sine x, and I get 1/2. Okay, so I'm looking for angles where sine is 1/2 and angles where cosine, sorry, is 0. Okay, so I know that cosine is 0 at pi over 2 and 3 pi over 2. And I know that sine is positive in quadrant 1 as well as quadrant 2. Okay, sine is y over r. And so I can see that my reference angle here is 30 degrees. Okay, so my angle here is pi over 6, and my angle here is 5 pi over 6. Now, as you can see, you're usually given an interval to solve along, but this one just says for all angles. So this is infinite. So it wants to know what are the solutions infinitely. So what we're going to do is we're going to say, okay, x equals, and we're going to take our first angle over here, which was pi over 2, and we're going to add a period of cosine times n. Remember, n represents any integer, positive, negative, 0, any integer, okay? And that will account for all angles where cosine is 0. And then I'm going to include 3 pi over 2 and do the same thing. And then over here, I've got pi over 6 and a period of sine n and 5 pi over 6 plus 2 pi n. And I am done. This covers all angles in which cosine is 0 and sine is positive 1/2. Okay, so let's look at another example. Okay, in this one, I've got tangent and sine within the same equation. So again, what you want to do is you want to move everything to one side. So I'm going to subtract sine x on both sides, just like that. And I can see that I can factor out a sine x. So I'm going to do so. And that leaves me with tan x minus 1 equals 0. Again, always double check that you factored right. Everything looks good. And now we're going to set our factors equal to 0 and solve. So I have sine x equals 0, and I've got tan x minus 1 equals 0. So if I move the 1 over, I've got positive 1. So now I'm looking for angles at which tangent is 1 and angles at which sine is 0. Okay? Sine is 0 at 0 and pi. And tangent is 1. Let's see, tangent is positive in quadrant 1, positive in quadrant 3. Okay? So of course, tangent is y over x. So I've got a 45, 45, 90 triangle here. So my reference angle is 45. So looking at these angles, I've got pi over 4 and 5 pi over 4. Okay? So I'm going to start the same way as I did in the previous problem. I'm going to list all of my primary angles here. So that's all the angles in one rotation, 0 to 2 pi. And for sine, I have 0 plus a period of sine, n, and then x equals pi plus 2 pi n. X equals pi over 4 plus 2 pi n. And then last, my angle down here, which is 5 pi over 4 plus 2 pi n. Okay? Now, this is for all angles, but as you can see, we are given an interval that is negative pi to 2 pi. So we're looking for all the angles between negative pi and 2 pi. Okay? So I might use this strategy here just to kind of help us along and change the 2 pi's just to match denominators. So really, I only need to do that down here. So instead of 2 pi here and here, I might say 8 pi over 4, just so I have a common denominator. Okay? So I'll take my first angle, which is 0. Okay? 0 is definitely between negative pi and 2 pi. Now, if I subtract 2 pi, I've gone too far to the negative. If I add 2 pi, that is an angle in my interval because as you can see, 2 pi is included. So that's good. Okay? And that's as far as we can go there. And then I'll look at pi, which is definitely in our interval. And if I subtract 2 pi, I'm at negative pi, which is also included. So I can add that one. But if I add 2 pi to pi, I'm at 3 pi, which exceeds our interval. Okay, so I stop there and I go to my next angle, which is pi over 4. Pi over 4 falls into my interval here. Now, if I subtract 8 pi over 4, that's going to go negative 7 pi over 4, which is too small. Okay, it goes too far into the negative. But if I add 8 pi over 4, I will exceed 2 pi, so that's not going to work. Okay, so then I look at 5 pi over 4, which is definitely between negative pi and 2 pi. Now, if I subtract 8 pi over 4, that gives me negative 3 pi over 4, and that will work. That is in my interval. But if I add 8 pi over 4, I get 13 pi over 4, which exceeds 2 pi. So that is it. These are all of the angles in the interval negative pi to 2 pi. Okay? So I hope that helps you with looking for a common factor to factor out and solve, and I'll see you in the next video.